Basic troubleshooting steps. Here I've logged onto the portal and I've navigated to the actual system that I'd like to take a look at. The first thing I'm going to look at is the last update. These are hourly updates from the systems, and I want to make sure that the data is current. Recall that if I take a look at the radio data page, I'm going to get real-time updates, but if I haven't been looking at the system for a while, this could be up to an hour old, but I at least want to see if it's checking in. Then I'm going to check out all the hardware. Am I seeing all of my coverage units? If I have a hub, it'll be shown. If I have extenders for coverage unit cables, they will be shown. Further down, I can check to see if there are any active alarms. If there is, and I select it, it'll bring up a window on how to resolve that alarm. If there is no alarm, such as there isn't here, then further down I can take a look at the last 100 alarms in the alarm history, just in case there's something intermittent that's only showing up once in a while. So that's all useful information. Then I will select the network unit or some other piece of hardware from the system, and it'll take me to that radio data page. I'm going to use this page to assess two main things. One, the donor signal quality, in case there's something I need to do to improve it. And then two, is there any feedback from the system that's causing lower gain and power? So on this page, I can take a look at the AT&T radios, the operator A, operator B, operator C, and D, and it'll show me what the two radios are doing. So the first thing is, again, what about the donor signal quality? I do take a look at the donor signal levels just to make sure they aren't too low or too high. The lowest value that the system will relay, because it doesn't want to relay noise, is minus 120 dBm RSRP. I'd like to see it be at least 5 dB above that. The SINR, signal to noise ratio, that's probably the most critical component of the system, or KPI of the system, because SINR is what drives data rates and actually bars on most phones. If the signal to noise ratio isn't optimum, or if any of these KPIs aren't optimum, there's real-time guidance in the portal. You'll get these triangular alert icons. If you select it, it'll give you information about how you might be able to improve the performance of this specific KPI. And I can also graph the information, right? Let's say it might be intermittent. Maybe the SINR is going bad just during a certain time of the day. I'd be able to tell by charting it. And if I hover my cursor over a data point, it's going to show me the actual measured information. And I can take a look at that data by last day, week, or month. So I'm going to take a look again at the signal level to make sure it isn't too high or too low. What's too high? There are certain rules in certain countries. If the power level is too strong, for example, here in the United States, you actually have to back off on your gain. Let's say RSRP was minus 40 dBm or greater, you might want to put some an attenuator actually on your donor feed to knock it down a little bit, because you don't want that FCC rule to kick in. How would I know that it kicked in? Because I would go down and chart the downlink power. It should be hovering somewhere between 10 and 16 dBm, depending on the channel bandwidth, and it's going to go up and down with loading. But if it's low, if it's really peaking at 0 dBm or minus 10, then I have a 10 to 20 dB issue to contend with. Then once I've taken a look at that donor signal health and aimed my antennas and done what I can to make sure that signal quality has been maximized, I will also go down and take a look at the coverage units. Now there are two things that I'm looking for here. The first one is, do I have a service antenna so close to my donor antennas that the system has, even after running its echo canceller, has had to drop gain and power to prevent an oscillation? You will see low donor downlink transmit power, and you'll see a downlink echo gain value that's too high. Now, this is a little bit advanced, but every Cel-Fi product runs its echo canceller at a different level. It depends on the architecture for the system. Here for the Quattro 4000, the target level is minus 3 dB or lower. If it's lower than -3, say -4 or -10 or -20, it means there is no echo that has caused the system to drop gain or power. But if it's sitting at -3, then it may or may not be reducing your gain and power. How do I tell? Well, I will chart the downlink power, and I'm going to take a look at the peaks again, right? Now, these peaks are all sitting around 10, 14. They're exactly where they're supposed to be. So I know that the power has not been compromised by echo. But if this chart was showing me that the power level was down, let's say around -10, when it should be greater than +10, then I'd say I have 20 dB of isolation to fix. And I'll go back to that main page where we took a look at the coverage units, and I can do this remotely. I will turn off coverage units one by one and go back and check the gain and see where it goes back up. Because when it goes back up, it tells me that I've hit on the right coverage unit that's feeding a service antenna that's causing the feedback to occur. And then I can tell somebody to go out and move that specific coverage unit or one of the antennas, service antennas that is connected to it. There's one other feedback to take a look at, and both of these feedback issues are actually very, very rare for commercial deployments because your antennas are up on the roof. They're generally very well isolated from service antennas in the building, but we're just going over them anyway. Another one is downlink system gain. I like to graph that. And I should see it'll be wavering a few dB, but what I don't want it doing is going to 0. Why would it go to 0? If you have multiple systems in the same building, which is very, very common, and they're actually feeding back in through each other, System A cannot echo cancel a signal that's coming in from System B. It'll lower its gain to get rid of an echo, but the echo isn't going away because it's coming from a different system. So it continues to compensate until its downlink gain is 0. Same thing, I go back out to the coverage units and turn them off one by one, and I'll try to find out which coverage unit is feeding back into some other system and then go create better isolation for that system. So that's pretty much everything I do when I'm evaluating something. I'll obviously come back and check when I'm done to make sure everything looks good. If you have any issues, please contact your point of sale or call Nextivity support. Thank you.